Hi, we're moving on to variation and standard deviation. And we'll look at z-scores a little bit. So we'll start with standard deviation and variance. There are some formulas for this that we need to use, and they look very complicated, but we'll take them into pieces. So variance is s squared. For some reason they use s. And then we have this capital sigma sign. It's like a fancy E. That means the sum of x minus, and then we say x bar squared all over n. So the standard deviation is just taking the square root of variance. So standard deviation is just going to be the square root of this whole thing. Okay, and I know that those look confusing, but I'll kind of show you how to break it down step by step. It's really not that difficult. So first we need to figure out S, or x bar, is just the mean. Okay, we know how to find the mean. So when I reference the mean, I'll do this x bar. N is going to be the number of population. So however many numbers you have, that's what n is. And then x is going to be just a value. Okay, and we'll look at that. So if we want to find a standard deviation by hand, first thing we need to do is find the mean, which is the x bar. And we already know how to do that. Add them all up, divide by the total. Then we need to find the difference between each value and the mean. So that would be, here's the value, and I want to subtract the mean. So that's that part of the equation. And we'll put this in a table to make it really easy to follow. Then I want to square each difference. So I find the mean. I'm going to take each of the numbers and subtract the mean. And then I will square all of those. So x minus x bar squared. And then I want to find the average of those. Okay, so find the average of the squares, which is kind of the rest of this. We add them all up, which is the sum. So x minus x bar squared, and divide by the total. So that's just kind of a fancy way of actually writing the mean. Okay, then to find, so that will give you the variance, but then if I want to find the standard deviation, I have to take the square root. Okay, and then that would be the square root of the whole thing, giving us our whole formula. Okay? So we'll look at an example to see how all of these things work. It's really not that complicated once you see an example. So our values are 50, 60, 70, 65, and 55. Okay, so the first step is going to be to find the mean. So what is the mean of all of these values? So if we add them up, we get 300 divided by, there's 5 of them, so the mean is actually 60. Okay, then I can go ahead and set up the table. So I'm going to have all the values, and then I'm going to have the values minus the mean, and then I will have the values minus the mean square. Okay, I'm just going to rewrite all of these. Oops. I'll rewrite all of these down in the x column. Those are all my x's. So 50, 60, 70, 65, and 55. Okay, so then the second part, so this is kind of step 2, is to find the difference between the value and the mean. So I'm going to take 50 minus 60, which gets me negative 10. 60 minus 60, which gets me 0, 70 minus 60, which gets me 10, 65 minus 60 is 5, and then 55 minus 60 is negative 5. Okay? Then step 3 is just to square those numbers. Okay, so I'm going to take column all the numbers in step 2 and I'm going to square them. So negative 10 squared, remember when we square it, they all become positive. That's kind of why we do this step. That's 100, 0 squared is 0, 10 squared is 100, 5 squared is 25, negative 5 squared is also 25. Okay, so we did the first 3 steps. Step 4 up here, I want to find the average of the squares. So this is all the squares. So step 4 would be to add them all up. So if I want to sum x, and that's what this looks like. So I know this looks really complicated because it's like a big math symbol and stuff like that, but all this is telling you is to add all these together. So when I add all them together, I get 250, but I want to find the average, so I divide that by 5 and get 50. Okay, so this is all step 4 down here. And then the last step is to just take the square root. So I will take the square root. So step 5, s equals the square root of 50, so s equals 7.07. So what this means is that each of these values deviate from the mean, which is 60, at an average of 7.07. Okay, so you can we can start to look at standard deviations and what those numbers mean. Depending on the number set, I want it to be relatively small compared to the numbers that I'm working with, because I don't want these values to vary from the mean that much. The further that these values are from the average, the less accurate we can be with making predictions and things like that. Okay, so that is standard deviation. I'm going to give you guys one to practice on your own, and then I will show you a different way to do it. So, for example 2, I want to find the mean and the standard deviation for the daily energy demand in a small town. So when we did this example, there was only 5 numbers. So we only had to do 5 rows here. This is looking at every single number. That's going to be a huge table. Also, finding the standard deviation like this can take a long time, because when you're talking about data sets, 5 numbers is not a big population. So typically when you want to find standard deviations, you have these huge populations. We don't want to sit there and do this by hand, okay? It's a little tedious. So what we are going to do is plug the numbers in the calculator. So make sure you have a graphing calculator. I need to get mine. Okay, so in your calculator, and we've done this before, I want you guys to click on Stat, and then Edit, and this will bring up your list. I don't know if you can see that. It's a little better over there. So if you have stuff in your list, like I have stuff in my list too, you can clear it out and hit Enter. That'll clear the whole list out. Then you just want to type in all the numbers into list 1. So, and that means all the numbers for Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So these are all the numbers of a whole month. They're kind of set up like a calendar. So we want to enter all of those values into list 1. Okay, so you can kind of pause the video, get those entered in list 1, and I'll show you how to find the mean and standard deviation using a calculator. So if I want to find the mean and standard deviation, we're going to hit, once everything's in the list, we hit Stat, scroll over to Calc, and I want one variable statistics, so the very first thing, and then I'm going to hit Enter, and then you might need to hit Enter again. Each calculator is set up a little bit differently, but we might need to hit Enter again so that it actually calculates it. And notice X bar, that's our mean. So you can use this to find the mean. So instead of adding them all up and dividing by the total, if you guys want to enter them in the list to find the mean, that is fine. So my mean is 43.16. Okay, and then so So this is the sum of all the values, so that's adding them all together. This is the sum of the squares. So we have these two symbols here, so S and lowercase sigma. These are both standard deviation. The S is for a sample standard deviation. We use the sigma down here, lowercase sigma, when we have the whole population. We will always use S, which is easy to remember, S for standard deviation. So my standard deviation is 6.12. So instead of going through that whole table, finding the mean, subtracting each value from the mean, squaring them, finding the average of that, and then taking the square root, you can just plop it in the calculator. Also notice N is 31 because there was 31 days in August, so that represented all the data values. So that will tell you how many numbers you put in. And then you scroll down here, and what do you notice about these 5 things? These are our 5-number summary for the box and whiskers. So you can use this one variable statistics to figure out Q1 and Q3 for the box and whiskers. Okay. So then we will move on to answer some questions about this data. So we have the mean and we have the standard deviation. Oops, this should be apart. Within how many standard deviations of the mean do all of the values fall? So I want to take the mean and I want to just keep adding 6.12 until I get to the highest value or subtract it. So first we need to figure out what the smallest value is and what the largest daily energy demand is. So if you look through the whole list, you'll notice that 33 is the smallest and 52 is the biggest. Oops, sorry, 54. Okay, so 54 is the largest. So in the middle, and sometimes we'll make a little chart. So in the middle is the mean. So 43.16, that's the mean. So if I add a standard deviation and subtract a standard deviation, so 1 SD for standard deviation, so I'm going to add 6.12, that gets me 49.28. That is 1 standard deviation above the mean. I can add another standard deviation, so this is 1 standard deviation. So I add 6.12 to that, and I get 55.40. This is 2 standard deviations above the mean. Okay. Then likewise, I can go, if I subtract 1, so I'm going below the mean now. This is 37.04, so this is 1 standard deviation below the mean. And then 1 more standard deviation will be 2 standard deviations below the mean. And that would get us a value of 30.92. So if I look, 54 was the max, so I only needed to add 2 standard deviations, and I only needed to subtract 2 standard deviations before I hit all my values, right? So I am within 2 standard deviations away from the mean, and all my values are going to be between that 30, almost 31, and the 55. Okay, so within how many standard deviations? We'll say 2 standard deviations. Okay, so all of the values lie within 2 standard deviations away from the mean. So the power company can kind of use this. Typically, statistically speaking, most values lie within 3 standard deviations away. So if the power company knows that they only need to supply power for 2 standard deviations away from the mean, they can kind of get a min and a max here, and because they don't want to supply too much power, because then they're wasting that energy. On the flip side, they don't want to supply too little power, because then people will be out of energy. Okay, so then how many standard deviations away from the mean is 38.5? So now I'm looking at a specific value. 38.5 is below the mean. So I can take 43.16 and kind of subtract it, and roughly close to 1 standard deviation below. So about 1 standard deviation below. Okay? Because we can use this chart up here and say, okay, well, if I subtract 1 standard deviation, and that's approximately close to that. Okay? Somewhere between 1 and 2 standard deviations away. And then I could kind of figure out in May, the mean daily energy demand was 35.8. If the standard deviation, so I'm looking at a different month, the month up at the top was August. So if I'm giving you the standard deviation of 3.5, so that's what we found in the calculator, the power company prepares for any demand within 3 standard deviations of the mean. Are they prepared for a demand of 48 megawatts? Okay, so let's figure it out. So my mean is 35.8. If I go up 1 standard deviation, okay, because 48 is bigger than 35. So I'm going to add plus 3.5 is 1 standard deviation up. That gets me 39.3. That's not quite there, so I'm going to add another standard deviation plus another 3.5. So that'll be 42.8. That's not quite there yet, so I'm going to add another, and they're giving me within 3 standard deviations, right? So here's another standard deviation, so plus another 3.5. And that will be 46.3. So they're only providing 3 standard deviations above. So we add it 3 times. That is not 48. So if someone wants to use 48 megawatts, they are not prepared for that. Okay, so no, not prepared. Because it's more than 3 standard deviations away. Or we can say it's more than 3 standard deviations above the mean. So they would not be ready for that. Okay. So, we're going to kind of look at what we do if we have numbers that are in between. Like if I'm not exactly 1, 2, or 3 standard deviations away. This will also lead us into some of the probability, which gets kind of fun. So if we don't know exactly how many standard deviations away we are, we have the z-score. So it's a little formula that will tell us the number of standard deviations that a value is from the mean. So we want to know how far things are from the mean because the mean is the middle of my data, right? If it's closer to the mean, it's more accurate than if it's further away. So z is going to equal x, the value, minus x bar over s. Okay, so it's the value minus the mean over the standard deviation. So pretty simple. So if I give you, the mean is going to be 85 and standard deviation is 6, find the z-score of a value of 76. Okay, so super easy. I'm going to take the value minus the mean and divide by 6. So just a note in the calculator. If you type this in the calculator, you either need to do 76 minus 85, hit enter, and then divide by 6, or you could do 76 minus 85 in parentheses divided by 6. Okay, but you cannot type in 76 minus 85 divided by 6 because that will get you the wrong number. Typically, z-scores are between -3 and 3. Okay? If you get a huge number in the double digits, you probably did something wrong. So this is negative 1.5. So it's negative, which means it's below the mean, which we can look at it and clearly see it's below the mean. So 76 is 1.5 standard deviations below the mean. Okay, so if I'm not exactly 1, 2, or 3, then we would need to use the formula, or you could always use the formula. Okay, so then last example, so the mean is going to be 76, the standard deviation is 3.5. Find a z-score for a value of 84. Okay, so find that z-score, and then also make sure to note whether it's above or below the mean. Alright, so for figuring this, it's going to be 84 minus 76 divided by 3.5. We type that in the calculator, 2.29. So 84, it's positive, this number is positive, is 2.29 standard deviations above the mean. Okay? So we will be working more with standard deviations and kind of using them to figure out the probabilities. So if we have a nice normal curve, if I know these numbers, I automatically know the probability of getting that number, okay, which is kind of cool, and we'll look at that a little bit later. So if you guys have any questions, please make sure you are reaching out, and have an excellent day.